Good evening, everyone. In the last session, we have started our discussion related to Docker. All right. So Docker logo is like a ship symbol, right? Docker logo is like a ship symbol. That means easily transferable, easily transferable. So for heavy weights, we are going to transfer by using containers in the ship from one place to another place. That is the logo for the Docker. So there is a meaning why they have used this ship logo also. Let's try to revise the concept that we discussed in the last session. Now, when we are going to talk about Docker, so Docker is a containerization software which we are going to use as part of our applications. So first of all, what technologies we are going to use in the application development? What is application development stack? So in the companies, we are going to develop several projects. So what is the tech stack of those projects? Let's try to understand. For the application, HTML content and template, web pages will be available. Front-end components will be available for our application. So whatever you see on the browsers, so everything is called as front end, that is user interface. So to develop that user interface, developers will use HTML, CSS, and they will use some client-side frameworks like Angular or React to develop UI. HTML, CSS, JavaScript, Angular, or React, all these technologies will be used to develop only front-end part of the application. Front-end part nothing but user interface. Then here, build tools will be available for a project like Maven or Gradle. Servers will be available. Apache web server will be available to run our application, and backend technologies will be available. Server side runtimes and frameworks like backend can be implemented by using Node.js or by using PHP or by using Python or Ruby, .NET, Java. Like this, backend part will be implemented by using any one of the technology like Java, .NET, Ruby, Python, PHP, Node.js. All these things comes under backend part. So to run our applications, we need a server. We are going to use Apache web server. And to build our project, we need to use Maven or Gradle. For front end, we are going to use Angular or React. CSS will be available for styles. HTML templates will be available. Now, along with these things, for the database, we are going to write the logic to communicate with the database. So for our application, we can use any one database like MySQL or Oracle or MariaDB or SQL Server or MongoDB. Like that, multiple databases are available in the market. So one of the database we are going to use. Along with these things, some other services also we are going to use as part of our application, like Redis Cache, which is used to improve performance of the application, and Apache Kafka also will be used to use as a now Apache Kafka is used as a message broker, which is used to exchange the messages from one application to another application. To develop event driven applications, nowadays people are using Apache Kafka, and GitHub will be available as a version control software. So all these technologies are used in one project development. One project means only Java will not be available. Only with Java we can't develop entire project. So Java project means along with Java, some other tools, some other frameworks, some other technologies will be used to develop that entire end-to-end application. So for the application, front-end components will be available and back-end components will be available. Database components will be available. So front-end we are going to build by using HTML, CSS, Angular, React. Backend we can implement by using Java, .NET, Python, PHP, Node.js, Ruby. Databases we are going to use MySQL, MariaDB, SQL Server, MongoDB. Message queues we are going to use like Apache Kafka. Caching techniques we are going to use like Redis, and GitHub version control software we are going to use. Maven or Gradle we are going to use as build tools. So all these technologies we are going to integrate in order to develop one application. This is called application development stack. All right. So whenever we develop this application, front-end components, back-end components, database components, some environment libraries are required. So here, whenever we develop our application, that application we are going to execute in multiple machines. Some people, I want to run my application in a laptop. I want to execute my application in a desktop. I want to execute my application inside a server. I want to execute my application in a tab. So here, for our application development, several components are involved: database involved, libraries involved, backend components involved, front-end components involved. If I integrate front-end, backend, DB, environment libraries, then only our project will be ready. Whatever the project we developed, that project we need to execute in multiple machines. So it may be a computer, it may be a desktop, it may be a tab, it may be a node, it may be a server. Like this, in several machines, I want to run my application. So when I am running my application in the several variety of machines, what is the guarantee all the components will be compatible with all the machines? Can you guarantee all the components will work in the laptop? Can you guarantee all the components will work in the desktop? Can you guarantee all the components will work in the server, node, tab? There is no guarantee. Some dependency will be available with the operating system. Which operating system we are using in that machine, which version of the software we are using in that machine, which database is available in that machine, which version of Java available, which version of Git available, which version of Angular available, which version of Node available. All these things we need to understand. We need to take care of all the infrastructure in order to run our application. If I want to deliver my application to the client, I want to test my application is working in all the machines or not. If my application is working in all the machines, then only confidently I can release my application to the production so that public users can access. So can you guarantee all the application development stack will support for all the machines we are using? Whatever the development stack we are using to develop a project, can you guarantee the development stack will support for all the environments or all the machines we are using to run our application? There is no guarantee. Some machines may have Windows, some machines may have Linux, some machines may have Java 1.5, some machines may have Java 11. So environmental dependencies will be available. So here you need to take care of development stack in all the machines to run our application. It is a challenging thing. Whenever you set this development stack in all the machines, some people will say that the code is not working in my system. Some people will say that the code is working in my system. Both developers are belongs to the same project. Both people are belongs to the same project. In one developer machine, that code is working. In another developer machine, the code is not working because of the operating system. You use a Mac OS, they use Windows. You developed the application using Java 1.8, they have Java 11. You used MongoDB version 3.6, they are using version 4.2. So here the development is tech stack. Whatever the technologies we use, which version of the technologies we use, those technologies are not common in all the developers systems. In all the developers systems, the tech stack is not common. So then the code which is working in one developer system, code is not working in another developer system because of some issues with the environment. So these are the common problems we are going to face when we are working with project development. Now, how to resolve these problems? How to resolve these problems? In order to resolve these problems, what people will do? People will go for virtualization concept. So they are going to take one machine. In that machine, they are going to install hypervisor software. They're going to take one machine. In that machine, they are going to install hypervisor software. What is the purpose of a hypervisor? By using hypervisor in one operating system, we can install multiple other operating systems. Those are called guest operating systems. Host operating system is available. In the host operating system, we are installing hypervisor. Using that hypervisor, we are installing guest operating systems. In the guest operating systems, we are installing all the development stack, whatever the Java we need, whatever the database we need, whatever the Java we need, whatever the database we need, whatever the server we need, which version of the server, everything they are going to install in the guest operating system, and they are going to run the application. So you no need to purchase multiple computers. By using hypervisor, in one computer we are installing multiple guest operating systems and we are running our application. There are advantages available. Can you read what are the advantages? Multiple operating systems we are running in the same machine, easy maintenance, easy recovery, lower total cost of the ownership. Instead of purchasing 3 machines to run my 3 applications, in one machine I'm installing 3 operating systems, I'm running my application. Cost is less, maintenance is easy. In the same machine I have 3 operating systems. Advantages. What about the drawbacks? Whenever you install multiple operating systems in one machine, it is going to take a lot of time to start the machine. Applications performance will become slow because system resources will not be sufficient. Multiple VMs lead to unstable performance. Hypervisors are not efficient as a host OS. Hypervisor is a guest OS. So how the speed is available for the host operating system, same speed may not be available for the guest OS because multiple operating systems are sharing the resources of one computer, then definitely performance will become slow. And its system will take more time to start because hypervisor is available. In that hypervisor, 3 operating systems are available. Earlier, if people want to test the application with multiple flavors, then they use it to go for virtualization concept. They use it to go for virtualization concept. There are some advantages available as well as some disadvantages also available with the virtualization. To overcome this virtualization, containerization concept came into picture. Instead of installing multiple operating systems on the machine, we are going for containerization. Whatever the development stack is required for the application execution, we are going to create as one container and we will execute that container in the host operating systems. You no need to install hypervisor. You no need to install guest operating systems to run your application because we are not going to follow virtualization concept. Virtualization concept is outdated concept. It is not recommended. Currently we are going for containerization concept. Container, that means a package. Container means a package. Our application is available, application code available. To run that application code, we need some stack of softwares, databases, backend components, front-end components, servers, version control softwares, build tools. Lot of things are required in order to run our application. Application dependencies will be packaged together as a container, and we are going to run that container. So in order to run the container, container engine will be available. In our machine, we are going to install container engine. Once a container engine is available, we can run multiple containers. Every application will be executed as one container. Every application will be executed as one container. Earlier, what happened in the earlier slide? So to run the 3 applications, 3 operating systems I have installed. To run 3 applications, I have installed 3 operating systems. But here, am I doing 3 operating systems installation? No. Every application requires a different stack. So to run the application with a different stack, I'm going to use a container concept. Right? What are the advantages? Containers are same OS kernel are lighter, smaller. Containers are lightweight. Better resource utilization compared to VMs. Boot up process, that means how much time your system will take to start will be speed. So when you compare virtualization and containerization is the recommended software. All right. When you compare virtual machine and Docker, virtualization and Docker, size, virtual machine size is like a elephant, Docker size is like a rat, very small. Startup process, virtual machines will take lot of time to start, like tortoise. Docker, cheetah, very speed. Integration, when I want to integrate the things, you will get a headache. if you want to go with a virtual machine. But in the Docker, you will just do that within fraction of minutes. Happy. So can you see symbolically what are the differences between virtualization and containerization with respect to size, with respect to startup time, with respect to integration? Virtualization size is like an elephant, very big. Docker is like a rat, very small. Virtualization startup is like a tortoise, very slow. Docker startup is very speed like cheetah. Integration of the application components are a hectic process when you go for virtualization. With the Docker, it is very simple. So here, when you compare virtualization and containerization, which one is recommended to run our applications? Virtualization is recommended or containerization is recommended to run our application now? Containerization is recommended to run our application. Got it. What is the meaning of containerization? I want to run my application in multiple machines. Multiple machines. Some machines are laptops, some machines are desktops, some machines are nodes, some machines are servers. I want to run my application in multiple machines. Those machines are having different configurations, different softwares, different operating systems are available in those machines. Now I want to install front-end components, back-end components, DB components, environment libraries in all the machines. It is difficult. So that's why what I will do is I will package my application required components as a container. I'm going to run that container. Everything I will keep in one container, my application code and what is required to execute my application. Everything I'm going to keep in a container and I'm going to execute that container in the machine. Everything I'm going to keep in a container and I'm going to execute that container in all the machines. Installing this tech stack, installing these softwares in all the machines is a difficult process. We don't know which version of the Java we need, which version of the database we need, which version of the libraries we need, which version of the front-end components we need to run our application. Instead of we are doing that, we will package everything as a Docker container, and a Docker container we are going to run in the multiple machines. When you run the Docker container, when you create a Docker container for your application, container will take care of everything which is required to run our application. We just need to execute the Docker container in the multiple machines. Everybody will say that if the container is executed in one machine, that means definitely it will execute in any machine. Everybody feel very happy, working for me, working for me, working for me, because container is going to take care of the tech stack which is used to run our application. Are you guys clear with what is virtualization and what is containerization? Are you guys clear with this? What is virtualization and what is containerization? Come on guys. Good. Now, so in order to achieve containerization for our applications, we are going to use Docker. We are going to use Docker. So what is Docker? What is Docker? Docker is a platform for packaging, deploying, and running our applications. Docker is a platform for packaging, deploying, and running applications. Docker enables you to separate your application from your infrastructure so can deliver the softwares quickly. So you can separate your application from your infrastructure and you can deliver the projects very easily. Docker packages software into standardized units called containers that have everything the software needs to run, including libraries, system tools, code, and runtime. Whatever the tools, whatever the libraries, whatever the softwares that we need to run our application, everything will be taken care by Docker. So how Docker is going to take care of these tools, environments, libraries? Docker is going to maintain everything as a container. In the container, everything will be available. By taking the advantage of the Docker methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing the code and running it in the production. So if you generally, whenever you write the code, in order to run that code in the production, lot of configurations, lot of installations we need to take care. But with the Docker, we can reduce that time because We will just tell to Docker only one time what is required to run our application. Then Docker is going to take care of everything which is required to run our project. What softwares are required, which version of the software is required, what libraries are required, what tools are required, what runtime is required. Everything will be prepared by Docker. So as a developer, they will just write the code. Docker will take care of the infrastructure to run that code. So Docker is a containerization platform. So what is the Docker architecture? How the Docker is going to work? How the Docker will understand what we need? How the Docker is going to understand what we need? So here, whenever we are developing an application, what dependencies are required, what softwares are required to run the application, everything we are going to mention in the Docker file. So for our project, if you want to develop a project by using Docker, so Docker will take care of everything. How Docker will understand which version of Java required, which version of the database required, which version of the build tool is required, which version of the software is required. For the Docker, we are going to give a input using a file called Docker file. In the Docker file, we are going to write all the configuration which is required to setup, which is required for our application. Docker file is the input for the Docker software. For every application, one Docker file we are going to create. Docker file contains the information which is required for our project. Docker file contains the information which is required for our project. So once the Docker file is created, we are going to build that Docker file. Docker file is input for the Docker software, which contains infrastructure details for our application. Docker file we are going to build. When we build the Docker file, a Docker image will be created. First, we'll create a Docker file for the project, and we are going to build that Docker file. When we build the Docker file, it is going to create a Docker image. Once the Docker image is created, we are going to run the Docker image. So Docker file will be created. Docker file we are going to build, then Docker image will be created. Once the Docker image got created, we are going to run the Docker image. When you run the Docker image, Docker container will start. That container contains everything. That container will have everything. Our application code, our application infrastructure, everything will be available in the Docker container. That container you can execute in any machine. You no need to install the softwares, you no need to set up anything to run your project, because Docker container will have everything to execute your project. You just need to execute the Docker container in the computer. That's it. So how we are going to run our applications using Docker? For our application, we are going to create a Docker file. In the Docker file, we are going to specify what softwares are required and which versions of the softwares are required. We are going to build that Docker file, then it is going to create one Docker image. Once the Docker image is created, we can run that Docker image. When you run the Docker image, it will prepare a container. Container will set up everything to run your application. So this is architecture of the Docker. Docker file, Docker image, Docker container. Now, these Docker images we are going to store in the repository. Docker images we can store in the repository, that is Docker Hub. There is a Docker Hub. In the Docker Hub, we can store our Docker images. Now, Docker terminology. Docker file. What is a Docker file? Docker file contains the configuration required for our application. So Docker software will use the Docker file to prepare image for our application. Based on the Docker file, we are going to prepare a Docker image. Docker images we can store in the Docker Hub. Docker Hub is a centralized location where we can store our Docker images. Right. Then Docker registry, we can register those images there. Docker client, Docker container, like this. Docker client machine will be available. Whenever we execute any Docker command, Docker client will start. Docker client is going to interact with the Docker engine and it is going to execute those commands. So whenever we run the image, then container is going to start. The full architecture of the Docker. Can you see the full architecture of the Docker? Create a Docker file, then build it, Docker image will be created. Docker image we can take and we can run the Docker image. Whenever you run the Docker image, then Docker container will be created. Docker container will be created. Docker file will be available. We are going to build the Docker file, then Docker image will be created. When the Docker image created, we can store the Docker image in some location and we can pull the Docker image wherever you want to execute. You can pull the Docker image wherever you want to execute and you can run that image. Whenever you run the image, then Docker container will be created and the Docker container is going to execute. It is going to execute. All right. Docker commands. So there are some commands available in the Docker. So how to work with the Docker? We are going to learn all these commands. Don't worry. So before going to understand these commands and all, are you guys clear with this? What is the Docker? How Docker is going to execute? What are the advantages of going for Docker? Are you guys able to understand what are the advantages of going for Docker? Are you guys able to understand what are the advantages of going for Docker? Come on, guys. Yep. Tell me, what are the advantages of going for Docker? What are the advantages of going for a Docker? Come on. What is the advantage of going for Docker? People are not responding. Docker is going to set up all the softwares which are required to run our application. Application dependencies can be integrated by Docker. So Docker will take care of all the softwares which are required to run our application in any machine. So it is called containerization platform. Docker is a containerization platform. Easily we can run our application by using Docker containers. Easily we can run our application by using Docker containers. So if you have Docker for the project, that project you can execute in any platform, in any environment, in any machine, because configurations, tools, versions, everything will be taken care by Docker to run our application. All right. Now, in order to use this Docker, we are going to install Docker software. We need to install Docker software. Okay, so how to set up Docker software? I'm going to install Docker in Amazon Linux. So I'm going to take one EC2 instance. In that EC2 instance, I'm going to install my Docker. Let's go here. Go to AWS console. I logged in into my AWS console. Go to EC2 service. Log in into AWS. In the AWS, go to EC2 instances. Currently, no instance is running. Let me create one instance. Launch instance. Instance name I am giving as Docker VM. Docker server, I can say. Docker server. Amazon Linux I'm taking. Free tier eligible Amazon Linux. T2 micro instance I'm taking. T2 micro. Key pair. I can use a key pair which is Linux key pair, any key pair which you have already. I'm selecting my existing key pair. Select existing security group. I have some security groups, so I'm selecting my existing security group. The remaining stuff, you don't need to change anything. Click on launch instance. Now my EC2 instance got created, which is having Amazon Linux. My EC2 instance got created, which is having Amazon Linux. Fine. So once this EC2 instance got created, it will get one public IP address. Let's use this public IP. Let's connect to that EC2 instance by using Mobile Extreme software. I'm using Mobile Extreme software. By using this Mobile Extreme software, I will connect to my EC2 instance session SSH connection. I'm using public IP of this machine, public IP address of this machine. Username will be EC2 user, EC2 user. SSH settings, use a private key. So I have a private key for this, which is linux.pem file. I have selected Linux pem file. Click on OK. Yes, I connected to Amazon Linux. Present working directory /home/EC2 user. Who am I? My username is EC2 user. I connected to my Linux machine. Linux machine I have started in the AWS cloud virtual machine. I connected to that. Once we have connected to that, can we see the Docker info? Can we execute the Docker info command? What it is telling, guys? Can you see the Docker info? What it is telling now? Is the Docker installed in this machine? Docker is not installed in this machine. Is the Docker software available in this machine? Docker software is not available in this machine. Docker software is available or Docker software is not available. Docker software is not available in this machine. We need to install. So these are the commands we are going to use to install the Docker. So first I'm using sudo yum update. I want to update the existing packages in this machine. Okay, done. Then sudo yum install Docker. Directly I'm executing yum install Docker. Docker is getting installed in my Linux machine. Docker is installing in my Linux machine. Yes, Docker installation got completed. Then I want to start the Docker software. Sudo service docker start. I have started Docker service. Once the Docker service started, check Docker info. Can you see what happened now? Is it saying command not found or it is saying permission denied? It is saying command not found or it is saying that permission denied? Permission denied. So we installed the Docker, but EC2 user doesn't have a permission to work with this Docker. EC2 user doesn't have a permission to work with the Docker. So how to resolve this permission? How to resolve this issue? Add the user to Docker group by executing this command. So if you execute this command, this EC2 user will be added to Docker group. Whenever we install the Docker, Docker group will be created. I am adding EC2 user to Docker group by using sudo usermod -ag docker EC2 user. Add the user to the group. What is the group name? Docker. What is the username? EC2 user. I have added EC2 user to Docker group. Once it is done, let's check Docker info. Still we have a problem. Let's exit. Then do Control R. I've connected once again. Then Docker info. Now are we able to get the Docker information? Are we able to get the Docker information now? Yes. With this, our Docker installation got completed. It is very simple. Sudo yum update -y. Sudo yum update -y. it is used to update the existing packages in our machine. Then yum install Docker. I have installed Docker software. Then I have started the Docker sudo service docker start. Docker software got started. By default, this EC2 user don't have a permission to work with the Docker in this machine. So that EC2 user should be added to Docker group. So I am using this command to add the EC2 user to Docker group. Once it is done, I am going to see Docker info. When I see the Docker info, it is going to print that information. When I do Docker info, it is printing all the Docker information, which Docker software we have downloaded, the information of the Docker, it is printing. Once this Docker information is printed, we can execute Docker commands, Docker images. When I execute the Docker images, it is going to display what all the images available. Do I have any image? Do I have any image in my machine currently? Do I have any Docker image, or I don't have any Docker image? I don't have any Docker image. Now, if you see the architecture, first we need to create a Docker file. When we build the Docker file, Docker image will be created. When we run the Docker image, Docker container will start and it is going to execute. But currently, do you know how to create a Docker file? Do you know how to create a Docker file? How to write the Docker file? We don't know. Now here, first for our practice purpose, what I will do is I will take one existing Docker image. So Docker pull command is available, which is used to pull hello world Docker image. Docker images command is going to display what are the images we have. Docker ps command will display what are the containers we have. Docker images command will display, Docker images command is going to display what are the images currently we have in the Docker. And the Docker ps command will display what are the Docker containers running in our machine. Are you guys able to understand here? I have given some Docker commands. So Docker commands I have given now. What is the Docker-v? Which version of the Docker is installed in our machine? We can check it. Docker version 20.10. Docker version 20.10 is installed. Docker-v. Docker info, we have already executed that. The Docker software information it is going to display. Then Docker help. So if you want to get some help from the Docker, then you can execute Docker help. When you execute the Docker help command, it is going to print all the Docker commands that we can execute. Management commands, normal commands, all the Docker commands we can see here. By using Docker help command, Docker login. So whenever you execute Docker login, it will ask your username and password. Sir, what is this username? What is this password? These are the details of Docker registry. That means you can create a Docker account in the Docker Hub. So today I have sent you a message for you people in the Telegram to create an account in the Docker Hub. So Docker Hub is used to store our Docker images. I have given you a message today, create account here in the dockerhub.com. So whenever you create an account in the Docker Hub, then you can log in into your Docker Hub account. What is the Docker Hub? Docker Hub is a place where we can store our Docker images. We can store the image into Docker Hub and we can pull the image from the Docker Hub. So how to pull the image from the Docker Hub? Docker pull image name. Docker pull image name we can give. It is going to pull the Docker image from our Docker Hub. So first we need to log in into our Docker Hub account. Then we can push the image. We can pull the image. Docker images command, Docker ps command, Docker pull image ID, Docker run image ID, Docker build, Docker tag, Docker push, Docker RMI. These are the images of the, these are the commands of the Docker. Now let's see what are the commands available. Docker-v, there is a command. It is going to display which version of the Docker we have installed. Docker info, what the information about the Docker software it is going to display. Docker help, The most important commands of the Docker, it is going to display. Docker login. Docker login is used to log in into our Docker Hub account. So if you want to store the images, then you need to create one account in the Docker Hub, hub.docker.com. hub.docker.com. You need to create an account in the Docker Hub. You need to create the account in the Docker Hub. Okay. This is my username, Ashok IT. Continue. My password. Sorry guys. Now I have account in the Docker Hub. I logged in into my Docker Hub account. I logged in into my Docker Hub account. In my Docker Hub already one image is available. Okay. In this Docker Hub one image available. See, 10,000 plus people downloaded my image. 7 months back I have stored one image into Docker Hub. 10,000 people downloaded my Docker image. So similarly, you can create one account in the Docker Hub, hub.docker.com, where you can store your Docker images. Once you have a Docker image in the Docker Hub, you can download that image into any computer and you can run that image. So whenever you run that image, then what will happen? Docker container is going to create. Docker container is going to create. So here I have created a Docker image and I have stored my Docker image into Docker Hub. So if you create the account in the Docker Hub, then you can execute Docker login. You can connect to that your Docker account. Once you have connected, you can see how many images of the Docker available in your machine. Now you see, currently I'm executing Docker images command. Currently I'm executing Docker images command. Do I have any images? Guys, do I have any Docker images here? Do I have any Docker images here? Currently, I don't have Docker images. Docker images command will display list of Docker images. Currently, I don't have any Docker image here. Here, if any image you want to download, from the Docker Hub, then you need to give Docker pull image name or image ID. Docker pull image name or image ID you need to give, then it is going to download that Docker image from the Docker Hub. Got it? I am giving Docker pull hello world. Now it is downloading a image called hello world image. It is pulling a image called hello world image. Now let us see Docker images. Now can you see that I got a hello world image? From where it is downloaded that image? From where it downloaded that image, guys? Can you tell me now? Docker pull hello world. What is the purpose of Docker pull and what is this hello world? What is the Docker pull hello world? Hello world is the default image name available in the Docker. Everybody can pull this hello world image. It is a test image. Hello world image. Docker pull is the command which is used to download the Docker image. So now how to see the list of Docker images available in our machine? Docker images command. Currently I have one image called hello world image. I have an image called hello world image. How to run this image? Docker run image ID or image name. Here image ID is available. Give the image ID. Yes, I'm able to execute. Docker run image ID. Instead of image ID, I can give image name also. Docker images. Docker run image name. What is the image name? Hello world. Run it. Whenever I execute this Docker run hello world, what is happening? Hello from Docker. This message shows that your installation appears to be working correctly. You are able to install the Docker perfectly in your machine. Your Docker software working perfectly in your machine. Docker run hello world. Hello world is the default Docker image which is used to test our Docker setup. So whenever I execute Docker run hello world, that means it is running the Docker container for this hello world image. That container printed these details, which is printing here. Got it? If you want to see how many containers are running, you can go for Docker PS. Docker PS command is going to display the Docker containers which are executing. Are you guys clear with these commands? Docker-v, Docker info, Docker help, Docker login, Docker images, Docker PS. Docker login to connect to your Docker Hub account. Docker images to display the Docker images you already downloaded. Docker PS to display the Docker containers running in our machine. Docker pull image ID, which is used to download the Docker image from the Docker Hub. How to connect to our Docker Hub account? By using Docker login. Docker build, Docker run. What is the purpose of Docker run? Whatever the image we have downloaded, we can run that Docker image by using run command. For example, I want to create my own image. Here, we need to create a Docker file. By using Docker file, we can create the Docker image by using Docker build command. Once the Docker image created, I want to store the Docker image into my Docker Hub. So to create the image, to store the image into Docker Hub, we are going to tag that image with a version. Then we are going to use Docker push. If you want to remove particular image, then Docker RMI remove image command. RMI command is available to remove that image. So look at these commands of the Docker. Look at these commands of the Docker. Are you guys clear with this? How to log in into our Docker? PS will display list of containers. How many Docker containers are running in our machine? We can see the containers details by using PS command. Docker PS is used to display the Docker containers running. Docker tag means giving a version number for the image, latest image, or image 1.1, image 1.2, image latest, image previous, like that. Some tag, a name, ID card, like that. Push means store the image into Docker Hub account. RMI means it is used to delete the image. Build means create the Docker image. To create the Docker image from a Docker file. First, I will tell you how to write the Docker file. Then I will tell you how to create a new image by using build command. So in order to tell you how to build a image, first I need to tell you Docker file. So how to create our own Docker image? What is required to create our own Docker image? Docker file is required. Do you know how to write a Docker file? No. So first we will learn about Docker file, then we will build the Docker image, then we will run the Docker image. Docker images we can store in the Docker Hub. So everybody should have an account in the dockerhub.com. So please create the account in the dockerhub.com if you don't have. Already I have my Docker Hub account. I will log in into this Docker Hub. So tomorrow I will show you how to create a Docker image by using Docker files. Okay, guys, are you clear with this? Docker file, Docker image, Docker container. So we are going to work with these Docker commands. We are going to work with these Docker commands. Got it? Yep. So these are the steps that I have given to install Docker software in the Amazon Linux. Once you have installed the Docker, then you can pull this Docker image called hello world. It will come by default. Then you can see Docker images. Then you can run that image name. Create account in the dockerhub.com. Note, create account in Docker Hub. Create account in Docker Hub. So why we need to create the account in the Docker Hub, guys? What is the purpose? What is the purpose of creating account in the Docker Hub? Any idea? What is the purpose of creating account in the Docker Hub? Akhil, I told you to send a message to admin team, man. Admin team will give you. I will not give you that access. Admin team will give you that. Why we are using Docker Hub? What is the purpose of Docker Hub? to store our images. To store our images, we are going to use Docker Hub. So before coming to tomorrow session, all of you create the accounts in the Docker Hub. So tomorrow we are going to see how to work with this Docker Hub. We'll continue in tomorrow session. Thank you guys. So with this, we completed introduction part for the Docker and we completed Docker setup in the Linux machine. From tomorrow, we are going to work with this Docker commands. We are going to write the Docker files. We are going to create the images. We are going to build the image. We are going to create the Docker file. We will build the Docker file to create a Docker image. Once the Docker image is created, I will store the Docker image into Docker Hub. Then I will pull the Docker image and I am going to run the Docker image with the containers. I will show you all these details practically. So tomorrow we have a class at same time. Tomorrow we'll discuss about it. Thank you guys. Good night. We'll meet again in the tomorrow session. Bye-bye. Before coming to tomorrow, you need to set up Docker in your virtual machine and you need to create account in the Docker Hub. Then we will learn the remaining concepts. Thank you. Good night. Notes I will upload today, guys.